Hello, myself Professor H.K. Bangade from Department of Electrical Engineering, SMD College of Engineering and Research Center, Evla. We are discussing on the subject Basic Electrical Engineering, and today we will discuss on DC circuits. So in practice, the electrical circuits may consist of one or more sources of energy and number of electrical parameters connected in different ways. So the different electrical parameters or the elements, they may be resistors, capacitors, or inductors. The combination of such a different and different elements along with various energy sources, either it may be current source or a voltage source, that gives to a complicated electrical circuit, and generally that is referred as the network. So the terms circuit and a network are used synonymously in the electrical literature, and the DC circuit consists of only resistances and DC sources of energy, and the circuit analysis means to find a current through or voltage across any of the branch of the circuit. So this chapter or this lecture, let us includes the various techniques of analysis of the DC circuit. So not in today's lecture we'll analyze, but in the next lecture we'll analyze the different DC circuit. Now today we'll see what are the different terminology the DC circuit is there. Before that, let us look after the currents with electrical charge. That is the electric charge, and after that the different electrical elements that we will study. So what is electric charge? So we can define the electric charge as the quantity of electricity that flows in a given time or is held in a component such as a capacitor. And the symbol for the charge is Q, and the unit of measurement of the charge is Coulomb. So charges may be positive or negative. So like charges, there is a rules, a laws. The like charges repel each other, while unlike charges attract each other. So the next definition is for electric current. So current is the rate of positive charge flow. The symbol for current is I. The unit is coulombs per second, and will denotes it by amperes. So the I is equal to rate of change of charges. That is I is equal to dq by dt. So where Q is the charge in coulombs and T is the time in second. So now the current has a polarity, means direction of the flow. Depending on the flow direction, it has a polarity. Then next is the electric potential. What is electric potential or voltage? So the energy per unit charge expended in moving a charge from one place to another. Whatever the energy required to move the charge from one place to another, that is nothing but the energy that is utilized for moving the charges, and that expended energy is nothing but your electric potential. The symbol for voltage, electric potential is V. The unit is joules per coulomb, and we use as a volts. And V is equal to dW by dq. The W is the energy and Q is the charge in coulombs. So the potential is always referred to some points. So the convention for the potential is the potential between points A and B, it is VAB. It means that the potential A minus the potential B at B, that is VAB, is equal to VA minus VB. Then electric power. Now the amount of energy transferred per unit time, that is nothing but the power. The amount of energy transferred per unit time. And the symbol for power is P, and is measured in joules per second watts. So P power is always dW by dt is equal to dW by dq by dt, that is VI. Means P is equal to product of instantaneous values of voltage and currents. So as a positive charge Q moves through a drop in voltage of amount V, it loses energy. The energy change is QV. So the rate is proportional to charges per second. The ideal basic circuit elements. What are the different ideal circuit basic elements? That elements may be examples we can take as a resistor, capacitor, inductor, diode, whatever it may be. But the polarity reference for voltage can be indicated by plus and minus signs. So here the particular element is there, and through that particular element, current is flowing when a voltage of V is applied across here. That time the polarity reference for voltage can be indicated a plus and minus sign. So reference direction for the current is indicated by an arrow. So this is the current direction indicated by arrow. So the two terminals point of connections are there. The two terminals. This is terminal. This is any component. It will be diode. It will be resistor. It has two terminals, and across these two terminals we have to give the voltage. So it cannot be subdivided into other elements. Mathematical will describe by its current voltage relationship. Now, what about the reference directions? A problem like find the current or find the voltage is always accompanied by a definition of the direction. So here the current direction is shown. I is flowing through this branch. Their voltage is there applied across a certain elements. So is a plus sign and minus sign. So in this case, if the current turns out to be 1 milliampere flowing to the left, we would say I is equal to minus 1 milliamp. So if we look in the different direction, it is negative. So in order to perform circuit analysis to determine the voltages and currents in an electric circuit, you need to specify reference direction. So there is no need to guess the reference direction so that the answers come out positive. However, now the sign conventions. Suppose you have an unbalanced, unlabeled battery. You have an unlabeled battery. Here is a battery source is there. Okay. You don't know which one is the positive terminal and which one is the negative terminal of that battery, and you have to find it out. Okay. So you measure its voltage with a digital voltmeter. It will tell you the magnitude and sign of the voltage. So the digital voltmeter itself will tell you the magnitude and the sign of the voltage. So with this circuit, you are measuring VAB, that is voltage across points A and B. So the DVM indicates minus 1.401. So VA is lower, without it is negative. That's why VA is lower than VB by 1.401 volts. So which is the positive battery terminal then? So we have used the ground symbol for the reference node on the DVM here. Often it is labeled C for common. Sometimes it is on the digital voltmeter, ground symbol is there or C is written there. Okay, so which is the positive battery terminal? So from this DVM itself will tell you if it is a negative reading you are getting. So obviously A is negative and B is positive. So sign convention for power. So passive sign convention, P is nothing but the product of instantaneous values of voltage and currents. So here current I is flowing through this. So in this direction, in this figure I is flowing in opposite direction. Okay, so sign convention is here minus, here is plus. That's why the direction of current changes. Here plus minus. That's why current changes. Conventional, and this corresponding power in this circuit is P is equal to V and is positive power will be there. Here it is current is flowing in this direction, positive towards positive, negative. So the power is negative here. If P is greater than 0, power is being delivered to the gray box. Power is to be delivered to the gray box. If P is less than 0, then power is being taken or extracted from the box. Here in this case, power is extracted from this box, while in this case, power is delivered to the box. The power calculation, every element consume the power. Every element consume the power. So you can find out the power consumption by each and every element by simply you have to find the current flowing to that particular element, and you need to give the sign convention to that particular element, and you can easily get the power consumption by each and every element in this circuit. Thank you. This is for today.